Talk about algebraic expression next. Algebraic expressions are like math phrases that have contains variables, which are letters that could be substituted for a number. So before we do that, let's just review. Let's just the previous things. Let's see what your knowledge of. Frankie orders 2 hamburgers and a soda for lunch. A hamburger is $3 and a soda is $1. Generate an equivalent expression to show how much he paid for lunch. Then determine the value of the expression. So we know he bought 2 hamburgers. 2 of them. Each hamburger costs how much? $3. Then we know he bought a soda. 1 soda. Each soda costs $1. So this is an expression. It's like a math sentence. What's 2 hamburgers for $3 each? $6. What's 1 soda for $1 each? $1. So he spent $7. This is one way you could have done it. Some kids like drawing pictures. You could have drawn it like this way. We know we had 2 hamburgers, $3 each. Then we had a soda for $1. So 3 plus 3 plus 1 is 7. So either one would have given you an equivalent expression. So let's get, what is this expression again? This is an example of an expression. It is like a math sentence. As you notice, it does not have an equal sign. It does not equate to anything. So an algebraic expression, so what we're learning the difference between an expression and an algebraic expression is that we're going to be working with variable or a letter. So it contains a number, an operation, and a variable or letter. So what is a variable again? A variable is a symbol for a number we don't know yet. We don't know what this number is going to be. In the above example, x is the variable. For example, 4 groups of something take away 7. If I said that this variable or this symbol should be the number 2, I substitute the letter x with a 2. So I substituted, I replaced this x with a 2. So what's 4 groups of 2? 8. 8 take away 7 is 1. So this algebraic expression could equal to anything, depending on what we define the x as. So we can say x is equal to 3. So I substitute this x with a 3. What's 4 groups of 3? 12. 12 take away 7 is 8. Wait. 4, I mean. 5. 5. 12 take away 7 is 5. So, again, what is an algebraic expression? Algebraic expression has a number, a variable, and an operation in it. So, algebraic expression could be 5m. Number, variable, operation is multiplication. Could be m plus 4. Number, variable, operation. Could be 5 minus m. Number, operation, variable. And we can substitute or evaluate each variable with a different number. So, let's practice that. Let's go back to what we remember about dependent and independent, about finding the relationship inside a table. So these are the number of days, and these are the costs. What is the relationship? Write an expression from the table that can be used to find the cost equivalent to days x. I see the relationship is times 6. Times 6. So the expression is 6x. However, can you name other ways to represent this expression? You could have written it as 6 parentheses x. You could have written it as 6 times x. You could have written it as, because I have a lot of kids that do this, x times 6, which is okay. You can do x parentheses 6. They all mean the same thing. And next week, we're going to be learning something called commutative property. And commutative property is if you reverse it, it still be the exact same thing. 6x is the same thing as saying x times 6. 5 plus 2 is the same thing as 2 plus 5. 7 times 2 is the same thing as saying 2 times 7. Called commutative property. Commute means going back and forth. So the variable x can be replaced with any number. So I can replace this x with any number. What happens if I replace this x with day 15? What will the new cost be? So if I replace this x, let's use a different pen color, with 15, what will be the cost? 15 times 6 will be 90. Again, you have 6x. If I replace that x with a 15, 6 times 15 is 90. If I replace this x with a 15, 15 times 6 is still 90. So what we just did is called evaluate. You just evaluate, replace, or substitute its variable with a given number. So I know when I was in school, my teacher kept using, algebra teacher kept using, we are going to substitute, we substitute this, substitute that. So we're going to substitute letters, these variables, with different numbers. And you come out with a different solution. So evaluate each algebraic expression if a equals 3, b equals 4, c equals 1/4, and d equals -8. So I'm going to replace each one, I'm going to substitute each letter with one of these 4 numbers. So we're going to evaluate it, we're going to substitute it, we're going to replace it. It all means the same thing. So this is, again, these are all algebraic expression. Again, what makes an algebraic expression? As a variable, operation, and a number. So a plus 7. If I substitute, evaluate, replace a with 3, 3 plus 7 will be 10. B squared. If I evaluate it, substitute, or replace the b with a 4, 4 squared is 4 times 4. Remember, 4 repeats how many times? Twice. 4 times 4 is 16. 12c, or 12 groups of c. If I evaluated c as 1/4, what is 12 groups of 1/4? If you add 1/4 plus 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 1/4, that's 2. Plus 1/4 plus 1/4 plus 1/4 plus 1/4 is 3. Or you could just multiply it. 12 1 times 1/4 is 12 fourths, or 3. Replace, substitute, evaluate the d as -8. What's 8 divided by 4? 2. So what do you remember about negatives? When it's multiply or divide, it's a given dot. Same signs are positive, different signs are not, so it's -2. Next one, 4a plus 2. If I evaluate the a with a 3, 4 groups of 3 is 12, plus 2 is 14. Let me use a different pen color. Next one, 6b divided by 8. If we replace the b with a 4, what's 6 groups of 4? 24. 24 divided by 8 is 3. 16c squared. If we evaluate it or replace the c with 1/4, 16 1/4 squared. Ooh, do you remember how to find the exponent using fractions? So it's saying square the numerator, square the denominator. So 1 square, 4 square. What is 1 square, or 1 repeated twice? 1 times 1 is 1. What is 4 square? 4 times 4 is 16. So what is 16 groups of 1/16? If you add 1/16 16 times, you can do it that way. Or you can just multiply. 16, 1 times 1/16 is 16 over 16, or 1 whole. And last but not least, letter D. 4d minus 3. Let me extend this thing. So 4d is -8 minus 3. So I replace or evaluate the d with -8. So what's 4 groups of -8? -8, -8, -8, -8 is -32. Uh-oh. Do you remember how to minus a negative number? Change the minus to a plus, change the sign to the next. Then all you do is add them up as if they were a plus. If you have 32 negatives, 12, 30, 40, 50, 60, 70, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and you put 3 more, how many negatives do you have? -35. So in our next screen, we're going to skip that one. So what happens if you're given an algebraic expression? Can you substitute these letters these variables with different numbers. So, expression 15p plus 12r shows the total cost of buying P printed shirts and R plain shirts. Determine the total cost if you buy 2 printed shirts and 3 plain shirts. So your algebraic expression is 15p plus 12r. Again, what's an algebraic expression? As a variable, a number, and an operation. So we're going to evaluate or substitute the letter P with 2 printed shirts. And we're going to evaluate or substitute or replace the letter R with 3 plain shirts. So what is the solution? 15 groups of 2 is 30. 12 groups of 3 is 36. It adds up to $66. Next one. A penguin can swim at a rate of 17 miles per hour. How many miles can a penguin swim in 4 hours? Use the algebraic expression RT, which is rate times times, where R represents rate, T represents time. So we need to evaluate or replace or substitute these letters, these variables, with one of these numbers. 17 is the rate, time was 4 hours. 17 groups of 4 is 68 miles. And last but not least, the perimeter of a rectangle can be found using the solution algebraic expression 2L plus 2W, where L represents length, W represents width. Determine the perimeter if L is 6, or replace this L with 6, and I replace this W with 3. So what's 2 groups of 6? 12. What's 2 groups of 3? 6. It adds up to 18 units. So the perimeter is 18 units around this. Let's taking this problem, let's make it a little more harder. Did you know you can also use the expression of 2 parentheses L plus W, or 2 groups of L plus W? So the length was, let's go back to the previous screen. The length was 6. The width was 3. So if I substituted or replaced or evaluated each letter with these numbers, 6 plus 3, what would the perimeter be now? Will it be the exact same answer? Yes, it will. 2 groups of 9 is 18 units. So the question is, how did the answers compare? They are the exact same answer. They are equivalent. And because it's 2 groups of L plus W. Is this the same thing? There's 2 groups of L plus 2 groups of W. We're going to be learning something next week called distributive property, where you can expand this into 2L plus 2W. It means the exact same thing. So explain how you use order operations to solve this. Well, first of all, in order operation, remember gem das. G is for group. We did the grouping. E is for exponent. There are no exponent. M and D for multiplication division from left to right. You see any multiplication division? Yes, I do. 2 groups of 9 is 18. And then add and subtract from left to right. Well, there's no adding here. So this is algebraic expression. Algebraic expression contains numbers, variables, and operation. And then we evaluate or replace or substitute the letters with different numbers that came up with different solutions.